Okay, this time we are going to look at Ethereum data model or Ethereum concepts, I guess. And in order to understand what we can do with it, so the main goal is going to be trying to make a trading system on this liquidity pool feature, which is like the new DeFi or the latest DeFi, like hot stuff, I guess. And so before that, we need to get a bit more familiar with what it means, and primary with smart contracts under Ethereum. So let's go here, and okay, so okay, obviously we can read all this, which I didn't do, but I did quite a lot of that stuff. But fortunately, this is not super easy for us to comprehend like in one go, right? I guess the easiest way is this one. Get started with Ethereum. But there's a lot of buzzwords that may work out for you. But I prefer to understand from a technical perspective, which is about these three guys actually: Ether, which is the Ether, the wallet thing, and the apps. Well, so they say that Ethereum is built on Bitcoin, and it has innovation, like it's programmable. What does it mean? Oh, okay. So what does it mean? So first of all, what do they build on Bitcoin? So what do we know about Bitcoin? Right? We know about Bitcoin is that it's a cryptocurrency, uses a blockchain, and it's distributed. So what they okay, how to explain that stuff? It's not super easy, to be honest. Bitcoin is quite easier than Ethereum, but so maybe we start with Bitcoin. So Bitcoin, what you have is you have the idea of keeping people's it's like bank accounts basically. So when you go to your bank account, especially if you have online system, you will be able to log in and you will have the balances of all your accounts. And essentially you never see the currency itself. You never see the actual bills, the notes, and everything. So it's just going to be a number that appears on the website. Obviously, if you start spending money or if you earn money, this balance will change. But behind the corner, behind the curtain, all this stuff is actually done with the exchange of real paper money. And what happens is that the computer system that the bank maintains will keep record of your earnings or expenditures and adjust your balances accordingly. So if you go and pay a bill, like for example, you pay an electricity bill, you will give the account number of the power company, and then you make a transfer, and then the bank through their whole network of computers, they will ensure that your balance will be deducted of the payment, and the balance of the power company will be credited. There may be a fee somewhere, but if there's no fee, it's just going to be exactly the same value. When you choose to do it this way, you basically trust all these systems to operate without messing balances up, right? And if one day your balance it has offset, then you will probably call your bank and try to sort it out. But the thing is that you trust the bank or you trust the system, the centralized system, to keep track of all the records accurately. So that's all good and done, but that's not. There are some issues with that, right? And the main issue is that the the currency that is underlying currency, which could be any of your local currency, your government local currency, which would be like US dollar or euros or whatever. The government is able to issue or destroy their currency at will. Of course, there's governance system. So there's the treasury, there's a Congress, blah blah blah, right? Depending on your country. But at the end of the day, there's always going to be someone else. Well, of course, you can say you vote for them, but whatever. Someone else who's going to be in charge of controlling the supply of this money. So what Bitcoin tried to solve was that what if instead of using the power of your elected people, you use an established set of rules to govern this money supply. And again, this is all convention. So you switch from a place where one organism, the government, can create new coins, new bills, to a system where, as long as all the participants of this group, the group of Bitcoin users, the majority agrees on not changing the rules, then the rules remain the same. So this is where it's distributed, because the power of changing the rules is not on the hand of one particular group, but it's spread out, and it's all these participants who collectively have the ability to change the rules, but only if they have a majority. Of course, these rules have nothing spatial, right? It's not like there's a cosmologic constant or any relation to the physical world that says that the quantity of Bitcoin should be what it is. But it's just a set of convention. And as long as these conventions these rules, right, are followed by the participants, they will not change. That's all there is. And in order to enforce these rules, we have particularly what we call a protocol. Right? A protocol is it's a fancy word for saying the same thing instead of rules. Specifically in when it comes to like computers and technology, but protocols are really you use them more every day. Right? For example, you send a letter to the post, right, and they say you have to put the address in the middle of the envelope and not at the back. Then you're following a protocol, right? You're following a protocol because when you meet somebody, you say hello and you don't punch them in the face. Maybe later, but not right then, right? So the protocol of Bitcoin is establishes that who's gonna earn these coins, and it's the mining process, which we don't gonna get into, and it defines the way this currency supply is gonna be recorded. So likewise, like the example of the bank, what Bitcoin blockchain. So blockchain it's just a data structure. So in computer, you always have two things. You have the code, which is like the set of instructions that computers will follow, and the code is the result of putting into a machine a set of rules. So the protocol is like a set of rules, but mostly in words, like agreement between it's a formal agreement, and then the code is going to be like the implementation of these rules, of this protocol. So as long as you have the programs following the same protocol, so the same rules, you will have programs that are compatible. But essentially today in Bitcoin you will have only like a few implementations that are that people use. The main one being of course the Bitcoin Core, the version that originated from the guy who created Bitcoin. This version of the code is this program, and this version of the protocol is still very dominant. So you as a participant, say you want to become a user of Bitcoin, if you're gonna install that program, right? And this program is gonna try to find other similar program over the network. So there's like a discovery process where they try to locate each other, and you're basically trying to plug into a socket. So let's consider that this is like an ant here, a lot of tentacles, and all these guys are communicating. You come as a new node, new element, and your program is gonna try to find a peer, another node of the same, of similar, running the same program or similar program. And all this process is completely transparent, right? So you run the program, and then you will try to look for other guy, connect to the other guy, and then start exchanging data. The goal here is that eventually your node, your program, is gonna have the same data as the other people on the network. So I said there are two things. The first thing being the program, and the second thing is being the data, the right? So what's the data? Obviously, the data is what differs. So, for example, if you have a program that does shopping list, several people can install the same program, right? And obviously, when they start using it, they will not have the same shopping list, right? So the shopping list itself, the content of the shopping list, will be the data, right? So if you start your program, you will have nothing there. As if you install the new shopping list app, you will have nothing in your shopping list. But once you start using it, then your data will come. For Bitcoin, the data is the transactions, right? And then the first thing you will do at your node is trying to gather the past transactions that happen. So what's the transaction? Well, transaction in terms of currency is it's simply all the records of transfer between person to person. Well, in this particular, I simplify quite a lot, but let's say it's from wallet to wallet, so person to person, of some amount of Bitcoin. So in this system, Bitcoin is never actually tangible. You're never going to have a particular number of Bitcoin that's going to be like, okay, I have this, because it wouldn't work in the world of computers, because computers everything is like 0 and 1s, and everything is very easy to copy. So if you really have a Bitcoin file, we say a file that data that represents 1 Bitcoin, nothing would prevent you from making exact copy of that data, and now you have another Bitcoin. So obviously that's something that has to be prevented. So instead, what the system records is the transfers, right? So just assuming, let's say that you somehow acquired some Bitcoin, and now you send it to somebody else. Let's say you have 10 Bitcoin, you want to send 1 to somebody else. That transfer of 1 is will be from A to B, A being you, B being somebody else, and the system, by keeping track of all these transactions and then applying them, so it knows that you started by 10, you see this transaction, so then after that you would know that your balance is 9 now, and then that person will have plus 1 Bitcoin. It can reconstruct the balances of people, right? So the blockchain itself doesn't contain the balances of your wallets, of these wallets, but it contains all the transactions that made any shift any coins from wallet to wallet, right? So that is pretty much the way it works. So the other issue, of course, here is like, how do you enforce that? You make sure that somebody else is not going to pretend it's you and then spend your coins, your Bitcoin. And this is solved by signature, by digital signatures, right? So I'm not going to get into this detail because I don't think that's so important for understanding this stuff. The main thing that you need to understand is that the blockchain contains these transactions. It contains a bunch of other things actually to make the record and not temperable. So it's a very important feature, is that once you make a transaction and that transaction is put into a block, so we call it mine into a block, it would not be possible, or it would be possible by a great cost to change that. And that's the main feature, right? Because if that was not true, you could do something or like calling a double spend. You could send one coin to you said you have 10 coins in your wallet. You could send 10 coins to some user A and also send 10 coins to user B, right? So therefore, you will overspend the coins that you have. So that obviously needs to be prevented by the system. Okay, so assuming that is done by some rules that we don't get into detail, we just need to remember that what Bitcoin has is a record, so a series, a ledger of these transactions, right? And that's the only like meaningful model of Bitcoin blockchain. Now, moving to Ethereum, Ethereum is really different from Bitcoin in the sense that their goal is not only to keep track of currency balances. So if you take the model of Bitcoin, what you would say is that wallet addresses, again, simplify quite a bit, but we're saying that there are addresses that when you create a wallet, you will actually create a wallet without any balance in there. Anybody can create a wallet, but we will have zero balance. So the only thing that the wallet records is the balance, the quantity of Bitcoin that wallet has, and that's it. Ethereum is quite more powerful, in the sense that it also now it has the idea of wallets. So wallets have an address, and an address is just like your home address, except that instead of having something that is like words, which for humans is easier to understand, a wallet address is a bunch of numbers of 0 and 1s, right? And it has a particular fixed size. It's, let's say, I don't exactly remember, but it's 128 bits or 256 bits, so it's quite long. And you are not expected to remember your address by heart, right? But for a computer, it's very easy to actually store that address. It's just a pretty short series of 0 and 1s. And that number is so large that the chances of that you randomly generate the same series of 0 and 1s is infinitesimally small. So it's not going to happen. In probabilistically speaking, it's not going to happen. So these addresses, so now we're talking about Ethereum addresses, they can be of two natures, right? You can be like a Bitcoin address, which is the wallet address, and then that type of address contains also Ethereum balance, right? So same as Bitcoin, the wallet address would have Bitcoin balance, and in Ethereum it would have Ethereum balance. But there's a second type of addresses, and they are contract addresses. So you probably heard about like smart contract. It's quite popular, the term smart contract. And I think it's very important to just understand exactly what that means. So a smart contract is like a little program, right? So if you already program in the code, and you specifically program in object-oriented programming style, you have this notion of a class, right? So a class is basically something that contains data, and then it has functions that manipulates this data. Right? So these two together is like a small app, right? So let's say, like, for example, you can make a counter. You want to simply, your bouncer, and you want to count how many people have entered the club, right? So you would create a class counter. Inside there would be a field, data field, which contains the current amount of people in the club, and you would have one function to increment, add one to the to that counter whenever somebody comes in, and then you would have a function that gets you the current number. You could have more functions if you want. You could have a function that adds like several people at the same time, because if a group comes, you want to maybe add them all at the same time. Or this could be, of course, people going out. So you should have a function that decrements, right? So, of course, like without the decrement, you see that your class it doesn't fulfill the purpose. You can only like increment the counter. So therefore, you cannot keep track of really the use case, the real need that you have for your class, right? So as you program, and then you get the knack of creating the proper data structure and the proper set of functions that manipulates this data, right? And all this together is called the interface of your smart contract. Right. So your smart contract though is a bit special. So when you have this class, right, and then typically a class cannot do too much. I mean, if your application becomes larger and larger, you will have more than one class that work with each other. And if each of them would be a smart contract somewhere, and then your app, your Ethereum D app, which is distributed app, would be like combining, using all these smart contracts in several ways in order to meet a particular need, right? So it's pretty high level, but that's what it is. So at the source, right, at the principle though is that your smart contracts is just a piece of an app, right? In the same way as on your phone, you will have apps, right? You will have apps for me to-do list, to do like playing games and so on, right? So I have all these apps, right? And the difference though with Ethereum is that it wants to be the world computer. So what does it mean? It means actually what it wants is that if you take your computer, or if your phone is a computer, and you install your app, right? So let's say that we install the shopping list app. Even if we all install the same app, we are not going to have the same data, right? As soon as somebody starts adding something to their shopping list, we start deviating. His version of the code of the app will be the same, but the data associated will be different, right? And that's all good and done, because I'm not really interested in everybody else's shopping list. I'm only interested in mine. But in the applications where you want everybody to agree on something. So typically, for example, you want to agree that how much money you have in your bank account. You don't want to be, well, you may want to be able to change that at will, but other people would probably not be happy if somebody is able to create money at will. So the main thing here is that if you want to get rid of the bank and have instead the account managed by Ethereum, you would need Ethereum to be able to have one version of the truth, which is your current balance, and yet be able to manipulate it to pay bills and stuff, right? But you have to preserve the requirements that the bank followed, right? That when you pay a bill, not everybody can pay a bill. You have to be that it comes from you, and that you can't double spend the money. You cannot exceed the balance that you have, and so on and so forth, right? So the way that we would do that with Ethereum is that we want to make sure that if you have this app account management, let's say bank account management, uh, the state that it has, which is like the data that it has, the which would track the balances of people, would be the same for every participant in the network. Right? So it's distributed because we don't want one person to be only doing this accounting. We want everybody in the node in the network to be doing the same calculation, and we also want that calculation to reach the same result. Otherwise, we will deviate. If we deviate a little bit, if I do one node does run the program and then gets a slightly different output result than the other node, then very quickly the whole thing will deviate. Right? This is like the good old butterfly effect, where if you change one little thing after time, this is going to be completely different all over the place. Right? So the very important thing here is that all the smart contracts that runs on this network, they have to operate deterministically. They have to, if they receive instructions, the same instructions, they have to reach the same result. And that actually prevents a lot of cases for the smart contracts. There are many things, therefore, that the smart contract would not be able to do in order to have this property. So for example, the smart contract can only read the data that is part of this universe, his world, basically, and that world is a blockchain, right? This own state. So you would not be able, for example, to see if the weather is nice outside. It actually cannot even look at connect to a website, because let's say that the program, this smart contract, could connect to a website. Then that a node could be able to connect to a website, but it could be that another node is not able to connect because there are different countries and different conditions. Therefore, for one of the node, the result will be different than the other node. Right? So that's not possible. That's not acceptable. Right? So there will be no way. Smart contracts cannot talk to website, cannot not get the time, because time is also something that is relative. Cannot send email, cannot. So the list is long. Basically, anything that you think would make the app responsive, meaning that, for example, you want the app to trigger and wake you up at 9 o'clock. That's not possible, right? What the app can do is you can call functions. You can, so it's really passive. The app will be stay on in the memory of all these nodes, right? And then if you are a user, you can. So remember, this app have these smart contracts. They have an API, right? So for example, they have this increment counter API. So somebody can call that increment counter, and then the counter will be incremented by 1, right? And you can get the counter value, and the counter will be returned, right? But we cannot make the counter increment by itself, right? This has to come from the outside, and you can imagine that another way to see it is that smart contracts are not much more different than a calculator, than a cash register, or from one of these 4 operation calculators, right? You can type in something, and then they will change their state. They will calculate something for you. So it has some memory, but by itself it will not like give you the any result, right? So that is, I think, very important to know. Right? It's very important to know that this limitation, which means that, for example, your app cannot go and trade on the exchange. That's impossible, because that means that this smart contract would be able to talk to a website, to the outside, and that's not allowed. likewise, the smart contract, even if you could connect to a website, cannot remind you that it's time to pay your bill, right? That's also tied with time, and time is not something that is deterministic, because the time on one computer may not be the same as the time on another computer. Okay, so I hope this is, I mean, if you understand that the reason why this is impossible, I think it's quite easy to know what kind of functions the smart contract can do and what functions the smart contract cannot do. The smart contract has access to its memory, right? So here we had a counter, and the counter is something that is called is a state, right? It's data that is specific to that particular smart contract. If you choose to create a smart contract, initially they would have no data, but as your smart contract run, it can decide to claim, to access, to request data, to store information, and that information will be then also part of the node data, right? And of course you have to pay for this stuff. This is why there's this Ether currency. Whenever you call an app, or an app request for storage, because that storage is going to cost some people's money. If you ask for this counter, every computer is running this smart contract will have to store the counter somewhere, either in memory or on disk, and therefore they will not do it for free, right? So you have to pay for this storage. But that being said, this is a much more powerful model than Bitcoin, because Bitcoin, the only thing that was storable in the address was the balance. Here we're talking about actually full-fledged applications which can own some data space. Okay. But the limitation being that they can only compute things based on the data that is given to them, and possibly the previous data that they have calculated themselves and stored as a state, right? So that is actually, I think, most of the stuff we need to know before we get really into the details, right? So I think now what we can do is actually take a look at how we get started with smart contract development. So what I remember is that there's a network, Ganache Ethereum. Okay, so how do we work actually with this smart contract? So the thing is that when you develop for the blockchain, it's quite different than developing for your own computer, right? Because if you just write code, you will, in a computer, you can just write the code and then run it locally, running on your machine, right? Here you will not be able to do that, because that code is supposed to end up in somebody else's computer, right? And in order to bring that code to that guy's computer, you have to actually somehow put it into the blockchain. So it's not that you can put things to blockchain directly, right? There's a cost associated, and as you develop, you don't want to pay that cost if your program is not ready to be not fully ready. You could have bugs and they're still working on it. The thing with the code is that every time you have any change of a contract, you make one fix, we change something, it will lead to another smart contract address, because the address that the smart contract has is actually a hash of the content of the smart contract. So imagine you write a program, and somebody, the compiler, right, so we turn that program into instructions that the Ethereum machines can understand, and that set of instructions is then basically hashed. So they calculate a digest, like a very summary of that series of instruction. So if you change any instruction, you will get another digest, and therefore the smart contract will be different, and therefore you will have to do to repay for the submission, and you will also may also have to change other programs that actually refers to that smart contract. So all this is very painful and potentially very costly. So instead, what you would do, right, is deploy your own personal blockchain, right? So there's nothing that is different between the official Ethereum blockchain and your own personal blockchain, except that on your personal blockchain, well, your personal blockchain will follow exactly the same rules as the official Ethereum blockchain. But your personal Ethereum blockchain, you will only have the transactions and the code that you have put into there, right? And you also make the mining, the difficulty for generating new blocks extremely low, so that it's very easy for your own compiler to create new blocks. For the official blockchain, the difficulty is really high, so that it's not possible for any random dude to come and put block into the official chain, right? You actually have to spend a significant amount of resources, electricity resources, to be part of that block, to be part of a blockchain by generating a valid block. Because when you generate a valid block, you actually earn ether, and that's the only way to actually earn ether out of like thin air. Instead of so what we have is this development environment, which mimics the exact same working as the Ethereum blockchain in terms of rules. The rules will be exactly the same, but the starting point would be yours, would be ours, and then the data in there would obviously be very different than the official blockchain. Official blockchain has tons of transactions because it has been going on for years, and a lot of people have been participating into it. But your personal blockchain will just have your stuff, and basically it's your own little country where you can, even though you follow the same rules as the other country, you will be the only guy who's going to be in the ruling party. Okay, so that's the idea behind this environment. And Truffle and Ganache. So Truffle is actually a bunch of tools, right? We have the environment, and we have Ganache, which is another project for setting up your own blockchain. So this is before you could develop on the smart contract by connecting to one of the test net. So there's a different network of blockchain. Well, so there's different blockchains. So following this about the same rules, but in order for people to test their code, there's a net, there's a blockchain where the coins are free. And by free, it just means that you can go to a website and then ask for some coins, and most likely people will give you coins because they are known that in this testing environment, coins should not be for sale, even though there are some guys who are going to try to sell coins, and some people are going to be taken advantage of. But even like working with a testnet is more work, it's more difficult than having your own personal blockchain, and that's what they did with this project, Ganache. So we're gonna use this guy and this guy. All right. So and this one is just for front end, right? Okay, but that's gonna be part of the next video. So I'm gonna stop here for a moment.